another function type which is not the polynomial that we've been dealing with, which is the easiest case. So this one, the interval of interest is -1, 2. Point A is -1, point B is at 2. Step number 1, find the critical point. Find the critical point could be more than one. So that means we're gonna start with finding the derivative. Okay. And the critical point occurs where the f prime equals 0 or f prime is undefined. Undefined. F prime, how would you like to find the derivative for part B? You can type in the chat if you prefer, or you can turn on the microphone and talk to me. How would you like to find the derivative of x to the 2/3 multiplied by 2 minus x?
I'd like to multiply the x to the 2/3 power into the parentheses.
Okay, like expand them out first to have the two terms in a power form, right? That's what you were going to do, Jeff?
um, yeah, so you have two terms to work with instead of
Uh-huh. Okay. Okay, go ahead. So f of x equals, the first one is 2 times x to the power 2/3. Next term, what would be the power of the x? So x to the 2/3 multiplied by x to the first. What would be the simplified power of the new x?
I'll let someone else go through them.
Think about the property of the exponents. When you multiply the two exponent terms with the same base, what would you do with the power? What would you do with the power? You add the power, right? 2/3 plus 1. So then it becomes 2x to the 2/3 minus x to the 1 as the 3/3. So going to be 5/3 as a new power. So this is one way to do it. I saw Jonas said use the product rule. Yes, that's another way to find the derivative as a direct way because you see as a product. Okay, either one, you're gonna get the same. I'm gonna do both ways. Let's start it with the expanded way. Okay, from this f prime, we find the derivative term by term to get 2 times 2/3, which is 4/3, x to the -1/3 minus 5/3 times x to the power 2/3, right? Okay, so we have the, whoops, 2/3. We have the negative power. That's the issue. That's the one. This is more algebra involved when you find the derivative. Do step by step and take your time when you handle this kind of problem. I see the common factor 1/3. I handle that one first, and then 4 multiplied by x to the negative power. Write it as the positive power as a reciprocal of it, and then minus 5 times x to the 2/3. Okay, what you would do next, combine them in the same fraction using the common denominator. The first term has denominator x to the power 1/3. Second term denominator 1. So the common denominator would be x to the power 1/3. So what I could do, I have to make the second term to have the same denominator. So multiply the second term by x to the 1/3 over x to the 1/3, right? If we multiply again x to the 2/3 multiplied by x to the 1/3, same property that we did over there at the beginning, this will give you x to the power 2 plus 1 divided by 3, which is 3/3, or just the whole quantity x. You guys follow? So it becomes minus 5x. So this is the simplified form of the derivative when you use the expanded form. Oops, oh, sorry. All right. Based on what Jonas said, you use the product rule. So f of x equals x to the 2/3 multiplied by 2 minus x. Use the product rule. The first one, I already have the function f here. I avoid using f and g version. I use u and v, which I prefer most. So my u is x to the 2/3, and my v is 2 minus x. So u prime is 2 over 3 x to the negative 1/3. V prime is negative 1. Okay, so my f prime follow the product rule u v prime plus u prime times v. The u is x to the 2/3. The v prime is negative 1. U prime is 2/3 x to the negative 1/3 and multiply by v, which is 2 minus x. Again, both of them still algebra going on when you don't deal with the polynomial function. Okay, just be prepared. And this is similar case to the previous one that has negative power. Just rewrite it in the better form. We have negative 2 over 3 plus 4 over 3x to the negative 1 over 3 and minus x times the 2/3 x to the negative 1/3 to become negative 2 over 3 x to the 2/3. Now you see light terms here, which is negative 1 minus 2 over 3 becomes negative 5 over 3 x to the 2/3 plus 4 over 3 x to the negative 1/3. You get the same derivative eventually. Same derivative eventually. So from the two cases to find the critical point, so f prime equals 0 and f prime undefined. The the way that we justify it into the fraction form is for our convenience to find the critical point for two different cases here. The numerator equals 0 for the case that f prime equals 0. The denominator equals 0. As we know, when the denominator, what happens? The function is undefined, right? Undefined. As we write as one single fraction. So we can pull out one case at a time. For the derivative 0, we just take the numerator part of 4 minus 5x equals 0. And for the denominator, that's 4 minus 2. Just 1 second, please. So this minus psi. I want to make sure I don't miss anything. Plus side, this is negative plus 4 minus, so negative 3 minus 2. That's the x. Okay, I see what I got. Yep, sorry about that. So the numerator is 4x, 4 minus 5x, 0, 0. That for the case that the derivative is 0. For the undefined, gonna be the case at the bottom of the denominator equals 0. Okay, so that is the use of the algebra to find the critical value on top of finding the derivative, which is the must of the problem anyway. You find the derivative, get the right derivative, use algebra to adjust the form in order to find the critical value in the more convenient way, and then you just do the same process to find the critical value for each case. The f prime f prime equals 0, numerator is 0. So then the x equals 4 over 5 for that case. And for the case that undefined, we get x equals 0. And next, we're going to have to find out, are these 2 points on the closed interval negative 1 comma 2? 4 over 5 is 0.8. Yes, it's within this interval. X equals 0. Yes. So we keep these two as the critical values. Okay, critical values. So then what we have to do next, that's step one. Step number two, we're gonna find the function value at these two critical values, or f at 4 over 5, f at 0, and f at two endpoints, which is at -1 and +2. Okay, quick way, we're gonna use Desmos. Um, the function I'm gonna type in as x to the power 2 over 3 and multiply by 2 minus x, right? 2 minus x. So I have the graph. See, the graph looks very odd, right? At the point 0, you see, which is one of the critical point, you see the sharp turn. The sharp turn here is not a smooth turn. So the point 0 is still considered a critical point. Okay. And then the next one, the next function value, the critical value is at 4 over 5. So 4 over 5. The value is 1.034. So somewhere around here, that's it. 1.034. And the left end is -1. So just put in here -1. At -1 is 3. So at -1, the 3 right there. And the right end at 2, the value is 0, as we see on the graph. Right there, right there. Okay. So it's very convenient when you have Desmos available. So put in the value here. We have negative 1.034 for the first critical value. Second critical value, the function value is 0. The left end function value is 3. The right end function value is 0. The second part is done. Just mainly algebra. The next part, number 3, you compare these four numbers. What is the largest? The largest is the value 3. The lowest, we have two lowest value at 0. As you see on the graph here, we look for the absolute max, absolute min, right? Between -1, if I expand the graph a little bit bigger, so we target from -1 to +2, just from this end to this end, the highest at -1, okay, the highest right there. And the lowest, you have two locations to give you two lowest value at 0 and at 2. So that's the graph to explain the way that we do analytically way. Okay. So from this one, we can summarize it as uh, the absolute maximum value equals f at -1, which is 3. And the absolute minimum value means a function value, at 0 and also at 2 equals 0. So this is step 3, and this is the end of the problem.